In this video, I'm going to explain the operation and functionality of our electro-pneumatic shifting system that we designed for use in a Formula SAE race vehicle. Formula SAE is an international design competition that challenges students to design, build, and compete with a small Formula-style race car. These cars are driven at each competition by the students who designed and built them. Therefore, since most of these students are amateur drivers, simplifying the driver controls can significantly increase the performance of the vehicle. One of these driver controls is the shifting mechanism. This photo shows a typical shifter design for a Formula SAE car, which consists of a manually operated hand lever inside the cockpit, controlling a push-pull cable which is connected to the transmission. Although simple, this method of shift actuation is slow and is difficult to use because the driver must take one of his hands off the steering wheel every time he needs to shift. Our solution to this problem was to design an electromechanical system using paddle-operated switches on the steering wheel and a pneumatic linear actuator to provide the shifting force at the transmission. The system consists of two main assemblies, the paddle switches and the microcontroller mounted in the cockpit, and the actual pneumatic system which is mounted in the engine compartment. The paddle switches shown here allow the driver to control upshifts and downshifts without taking his hands off the steering wheel. The paddles themselves simply act as lever arms that actuate individual momentary switches when they are pulled. These inputs are then read by the Arduino and shifter shield mounted below the seat. The board's main functionality is to control the output to the shift solenoids using two MOSFETs. The other two MOSFETs are used to control secondary functions for the cooling system. The shield was designed so that it interfaced perfectly with the Arduino board, allowing both to be mounted securely inside a weatherproof enclosure. The pneumatic system mounted to the transmission consists of a clippered 5/8" pneumatic cylinder controlled by two Parker electro-pneumatic solenoids. When the Arduino receives input from either paddle switch, it sends signal to the corresponding solenoid, moving the actuator and shifting gears. A compressed air tank mounted beside the engine provides the working fluid for the actuator. Our original design intent was to use CO2 for this. However, through testing, the radiant heat of the engine was causing the pressure to rise inside the bottle, compromising the regulator O-rings. As a result, we decided to use compressed air instead to combat this issue. Throughout testing, the drivers provided very positive feedback of the system and commented on the ease of use and the intuitiveness of the system in general. As I speak, the Formula SAE vehicle is being prepared for competition, where the true effectiveness of the system will be put to the test. However, we are confident that it will perform as expected.